Yeah, as I said, I work at Seaborg Technologies, and today the topic of the presentation is to give an insight on what we are doing and what type of technology we are trying to develop and we are working on. So this presentation will not just be like pure technical. It will be much more on some on business case, some on markets, and of course on science and technology, and engineering, manufacturing, and everything. So it's kind of mix of everything. So I hope you guys like it. So Seaborg Technologies, of course, why are we here and what is the motivation for us? And of course, as many of the net zero companies, our key motivation is to have a net zero economy. And we just feel like the current policies are not going to take us there, and the stated policies are also not going to take us there. And there needs to be a drastic shift in technology and deployment to address the global carbon emission rising. And that's where we want to focus our mission on. And that's one of our vision. So where are we going to solve this problem is the key question. Of course, we want to solve the entire, that we want to solve this carbon emission problem across the globe. But our first case here is that we want to take into the Southeast Asian challenge, because carbon emission is historically linked with socioeconomic development, the ways of people living. And a lot of economic development happens in Asia, that's Southeast Asian. And in this region, it's a rapidly growing economy, but they don't have the climate or the geography to suit the deployment of wind and solar power. And they also have very, very limited geothermal and hydropower development. So they want to develop, they want energy. What do? They start building a lot of coal power plants. And they have around 300 plants to build in the coming decades. And it's really not good. It's not a very good outlook for the climate in a sense. However, also they have a huge population density. So if you combine all the Southeast Asian population, it's around like 700 million. So it's a considerable problem to solve, to give them clean energy and to give them affordable energy, because it's a rapid growing economy. And that's what we want to solve. So our vision is to transform the energy markets by deploying clean and cheap energy technologies. And it's not a quite straightforward task, because most of the time we say about clean energy in the West, but cheap energy in the East. It's kind of how they tend to talk. However, we need both. So because clean energy for the climate and cheap energy for sustaining the growing economy. And our main mission is here to kind of deploy the clean energy technologies at a rapid scale, using like conventional proven technologies for commissioning and manufacturing, so that it will reduce the cost eventually. Like Vincent suggested before, that's how you try to achieve economies of scale, because when you deploy a product rapidly, eventually the cost of construction and manufacturing goes down. So that's one of our major goals. And we want to use the shipyard serial production. And for people who don't know that, shipyards are something, let's say, it's a facility where they manufacture and mass produce a lot of maritime vessels. And we want to use the existing proven technology because we believe that they can also mass manufacture power plants. And since they are from maritime industry, our product is also focused on maritime. And that's why we focus on offshore deployment rather than onshore deployment. With that said, I'm just going to give a brief history of how Seaborg formed. So it was a very, very small company back in 2014 with a couple of people. And they were actually a consultancy service at the time to raise money to kind of build a new type of nuclear reactor and achieve their vision eventually. And in 2017 and 2018, they had the first two pre-seed rounds, and they got kind of settled in, and they had like around 11 people working in 2019. That's the time where they also got into the new technology qualification process, it's a maritime regulatory approval process where you can qualify a new technology and give it approval, and you can deploy it wherever you want. And in 2020, they went and they finally finished the first assessment for the feasibility stage, and they got the certificate for that. And by the time we were just growing up to 32 employees. And with that said, that actually prompted the first seed round, where we got enough money to actually develop the product at a rapid scale, and we have been growing rapidly since then. So as I said before, we want to use existing shipyard production facilities across the globe to mass manufacture our nuclear power plants. So we actually had our first partnership with Samsung this year, and Samsung is looking into how they can utilize their existing technology and how they can change it or modify it, and how Seaborg can leverage from their shipyards and what they are having in South Korea. So that's the brief history on how we have developed, and it's kind of an exponential growth in the past 2 to 3 years. And until now, we are still a privately owned and privately funded company. Our headquarters is in Copenhagen. However, since our market, the target market we're focusing is in Southeast Asia, they also opened new offices in Singapore and South Korea. And as for the partnerships, our current partnership is with Samsung, who's looking into our shipyard manufacturing and construction facilities. So enough of some business and market. Now let's go into some science and technology. So our product is called compact molten salt reactor. Each term has kind of a meaning to it. So first, let's start with the molten salt part. So conventional nuclear uses solid fuel like uranium pellets. However, we at Seaborg will be using salts, fluoride-based uranium salts. And what happens when you heat the salt, it becomes liquid, and that's the name molten salt. So we operate with fission reaction. No, fusion is nuclear fission, and fission reaction produces heat at the core, and you just transfer the heat through the fuel salt to a primary heat exchanger, where the heat is removed by another non-radioactive salt, which then passes the heat to a steam generator, where you produce superheated steam, and then just the conventional process, you use it to run the turbine and supply electricity to the grid. So that's one of that's the major core, that from a nuclear standpoint, we are using a new type of fuel. And there is a little bit caveat here, because I will not say anything about moderator for now, because that's where our real IP license. And that's what will also explain about the compactness. But currently, with that said, this is how, this is one CMSR setup. So from now on, I will just address compact molten salt reactor as CMSR. And how does this fit in an offshore maritime vessel? So we want to use barges, which is a maritime vessel, which can be used for multiple purposes. It's not self-propelling. You just stow it wherever you want to deploy it. So you actually can build a barge and have proper construction so that you can deploy whatever you want. So in our case, we're going to deploy our CMSRs, our nuclear reactors. And this is our normal goal. So one barge is what, so here, as you can see, we separate the barge to be like modules. So each module is kind of like an, let's say like an attachment. So you can attach multiple modules to make the barge longer or smaller or wider, whatever you want. And in our case, what we will be doing is take one module, and we'll be having 2 CMSRs, which will be operating for 12 years. And by the end of the 12th year, we will actually commission and operate 2 more CMSRs in the empty compartments, which you're seeing on the left side out here. And in this way, we actually reduce the number of fuel cycles we have from conventional nuclear, because in conventional nuclear, you have a fuel cycle every 12 to 18 months. depending on the reactor. And also, we want to have, and also molten salt reactors normally have a short lifetime, if you know about Oak Ridge experiments. However, we want to have a longer lifetime, so at least 24 years, and that's one of our goal, and that's why, and this kind of setup also enables us to operate it up to 24 years. And on the right side bottom, you can see like how it would be looking like with the shielding and containment, encompassing all the systems and the reactor core and all sorts. Even waste management is actually the back of it, actually. So,
hey, Vighnesh,
yeah.
So after 24 years,
Yes,
they just need to refuel is all? Like they could go longer than that, right?
I think I'll answer that question at the end.
Okay.
But I'll keep that in mind, because it's a very, very good question. Like, why 24 years? Why not more than that, right? So I just keep that question. I'll answer everything at the end. So as you can see here, each module can supply up to 200 megawatt electrical. So what is the scale-up ratio here? So our aim is to have this modularized design. So we can deploy up to 4 modules in one batch at a given point of time. So in this sense, so we can deploy up to 4 modules, 200 each, so maximum 800 megawatt electrical output. And since these are floating and you can tow them wherever you want, you can actually construct and manufacture it at shipyard, and you can deploy it wherever you want. And thus you have the flexible deployment based on which market you're addressing and where the client wants you to put your power batch. And flexible deployment also helps us during decommissioning, because we can again tow it back to a decommissioning facility where we can have a centralized decommissioning, and we can have waste management at a separate place when compared to the place where the batch was operating. And it's kind of a very big game changer in terms of site rehabilitation in nuclear. So, talking about game changers, so what are we trying to achieve here? So absolutely, we are not we are not using the conventional nuclear fuel. We are using liquid fuel. So in on itself is actually putting us into an advanced reactor spectrum, where we have to demonstrate a lot of things from the safety point of view, but at the same time from supply chain point of view. And on the other side, where we are going is we are moving from land-based conventional nuclear to like floating-based nuclear reactors, because it helps us not just in mass production in shipyards, but also flexible deployment. So what enables our flexible deployment would be actually the novel licensing approach. So FNPP here is just like floating nuclear power plants. So there are a lot of other projects from Russia, or even from Turkon, and there are a lot of other players who are focusing on, I think also there's Core Power from the UK, who are focusing on having floating nuclear reactors, and it actually requires a different licensing strategy, different thinking from a licensing perspective, because you're not just going to deal with the national nuclear regulators, but you're also dealing with the International Maritime Organization. So in that sense, we are already doing immense work in having good stakeholder engagement, both from maritime, and also we are currently involving with a lot of regulators to see how we can fit it. So that's how we want to deliver the product, because if we have a proper standardized licensing, it actually enables mass deployment, because not just having technology to mass deploy will help us, but we should have the license to operate it, right? The license to manufacture it. And that's where these parts comes in. So now going back a little bit in science, and this is where I will also talk about the moderator part, where we have the IP. So first, why are we using molten salt reactors? Because these reactors can actually operate at much lower pressure, like close to atmospheric pressure. So you don't need like big containments similar to conventional nuclear, but more than that, the salt itself can actually retain radionuclides. So a lot of experiments and research is going in to validate these claims and to verify these things. But that's what they have explored back in the 60s. And when I say retain radionuclides, like imagine if there is a severe accident and the salt spills out to the land, it will just, what will happen? It will just freeze out there. It will not emit any gas. So technically you can just go and clean them up. Of course, you would need some personal protection shielding, but it's not going to contaminate the entire space because all the radionuclides are going to be retained in the salt matrix. And the second one is like molten salt reactors enables us to operate for longer lifetime. Like it reduces our refueling timelines, and which increases the availability and capacity factor of which we can supply power. And our other goal is to use the molten salts and to have flexible reprocessing so that we can reuse the uranium from spent nuclear fuel far more effectively in our future CMSR power projects. And finally, of course, we can't start from zero because molten salt reactors have already been experimented and has been researched in the 1960s, were in Oak Ridge National Lab. So we take them as an inspiration, but we don't copy them like completely. So that's where we have our moderator actually. The issue with the moderator. So we want to operate molten salt reactors for longer lifetime. However, the experiences from MSRE experiments show that they use graphite normally as a moderator in molten salts because you cannot use water like conventional nuclear because water just reacts so bad with high temperature salt and it's kind of unpredictable. So what happened is that graphite actually expands and contracts because of radiation, and it also degrades over time due to some chemical properties. So to avoid that, so if it's like that, then you would have a very shorter lifetime, around like 6 to 7 years. However, to avoid that, Seaborg researched on multiple other options from a neutronics perspective and thermohydraulics perspective, and they figured out they want to use sodium hydroxide. So that's where our core IP is, and we are going to use the sodium hydroxide. It's just a common salt. We can't even say it as a salt. It's a it will be looking like pellet, which normally people use in day-to-day life. However, it is very highly corrosive. It has very excellent neutronic properties. And that's why we can have a very, very compact core where we get the terminology compact molten salt reactor. So the core itself gets compacted because sodium hydroxide has excellent neutron moderation properties. However, it's super corrosive. And until that point of time, there hasn't been a lot of people looking into sodium hydroxide, especially using it at high temperature. So we were the ones we thought, okay, neutronics is good. Let's think about chemistry. We didn't have much data, so we need to deploy a lot of R&D to figure out whether it's possible. And in Seaborg, we have a culture where we like to kill ideas. It's like you have a lot of ideas and you try to kill that idea. And if you can't kill that idea, that's where you have to go. And that's how sodium hydroxide is still prevailing because a lot of thought process went into killing it, but eventually we couldn't kill it, and we found a way how to control it and how to mitigate corrosion. And that's one of the main reasons why we can also have a longer lifetime, up to 12 years. So going back into some timelines out here, of course, I have talked about there's a need for changing and licensing approach, and we are working with stakeholders. So currently, we still proceed with ABS. It's called American Bureau of Shipping, and the qualification process, like I said before, a new technology qualification process, which kind of we finished the feasibility. So by the end of this year, we'll be kind of submitting a lot of documentation for concept and verification stage. and you'll get some good news next year, of course, on us going through the upcoming phases. So at the same time, we'll also engage with nuclear regulators to see how we can align uh, the IMO standards for maritime and nuclear regulatory standards. And the timeline going forward is that we want to deploy the first reactor between 2026 and 2028 and supply power, not just manufacturing and commissioning, but also supplying power is quite important. And then by 2028 to 2030, we want to get something called a type approval. Type approval in maritime means is that you don't have to get approval for each and every single maritime vessel you are manufacturing at the shipyard. So technically, if you can get a standardized approval for, let's say our power barge. So if the CMSR power barge gets a type approval, which means you can go and mass produce, and you don't have to actually go through the entire licensing process from top to bottom every single time when you're manufacturing and commissioning your nuclear reactor. So that's a very important step for us in the right direction, and IMO actually helps us to achieve it. And but we also have to do this in line with nuclear regulators. With that said, the final part, of course, we are growing at fast pace. We're quite big now, 100 people, maybe a bit small, but we are still hiring. So feel free to go and check our open positions, not just in technical, but we also hired marketing, business, legal, all sorts. So with that, I will just finish my presentation here, and I'm open to a lot of questions. I'm pretty sure a lot of you have a lot of doubts in what I presented.
Doubts, did you say?
Maybe, maybe. So Matt, yeah, I can start with your question.
Yeah.
Of course, there's in the chat, there are a lot of questions.
Yeah, can you refuel?
After 12 years, right? So technically, we have the 24 years, correct?
Yeah.
So from a maritime perspective, it is far more flexible to have like vessel approval for like 30 years. That's the standard procedure. So if it's 30 years for us, 24 years is good because it leaves us enough time to do decommissioning and dismantling and all sorts. So 24 is kind of a very good sweet spot for us. And if the market demands for longer refueling, then of course we would do it. But currently, this business case holds up with a lot of our clients.
So if you wanted to extend it beyond 24 years,
we can.
It's possible. And you can refuel a molten salt reactor. It's not like it's this system that, once it starts up and it runs out of fuel, it's done. Like it could be extended beyond that.
I mean, then you have to kind of make some design changes at a much early stage. And until now, it looks fine because refueling actually is a big issue with safeguards and nuclear security. And reducing the number of refueling cycles we have drastically increases safeguards by design itself. So it's kind of a very appealing thought process for an appealing business case for most of the clients, because you don't have to go through the entire regulatory hassle of verifying safeguards and validation and all sorts of that, or even monitoring. So we don't have online refueling. That's why even after 12 years, we are going to bring in an entire new set of reactors, and we're going to fresh fuel it, no online refueling. So I think Eric has a question. If you have to heat up everything to 350 or so to get it all liquid, get it flowing, how do you start the first time or restart it after it's turned on for maintenance? Absolutely, uncanny black stuff. you will have support systems to actually heat it at the first instance. So absolutely, we will have support systems to make sure that the salt stays liquid whenever we want. And black start is something which we explore. And if we need black start, we can have it. But also, the definition of black start is a bit different from, let's say, coal industry to nuclear industry. In nuclear industry, black start is normally used for, yeah, even Hannah asked, what is black start mean? It's like when you there's one meaning where you have like complete shutdown, like you can't, you need power to restart your entire plant. And how are we going to do that? That's one way of addressing black start. And there are some other definitions in oil and gas industry also for black start, because it's called black start because you burn diesel and you actually have fumes going out, which is black. So it's, they consider that to be an synonym for black start. Have you done any research into public perception or how do you plan to approach PR when seeking support from public or politicians? Absolutely. It's not just research. We have like dedicated team who are working not just in Southeast Asia, but also in Europe. So we are quite frequently being approached by politicians, by activists, and we have been giving a lot of information, sharing information with them. And so far, it seems good. We haven't heard significant or like any negative perception towards us. But we kind of expect to have some negative perception to see how we can do better. But absolutely, it's not just research, but like a lot of groundwork is going at the background to kind of enable politicians to get political support and all sorts.
Vighnesh, I was wondering if you could say a little bit more about the kind of heating up the salts. Do you have like, are there like electric heaters that you can like plug the barge into and into an external power source to heat up everything and get it liquid, or like how does that work?
You can do that too, or you can have like diesel firing systems and also heat it. So you can just you can have like support systems which supplies hot fluid which can melt the salt again.
Okay. All right. Cool. That helps. Obviously, if your market is going to be, or at least part of your market, a lot of places that don't have reliable electricity at the moment.
That's taken into account. For sure.
Right. You can only rely on them so much for
Absolutely.
Yeah. I was curious also, are you guys exploring like a leasing model? I know that's a popular thing to do with power ships, where you say, oh, okay, yeah, we'll help you out with electricity. It's going to cost you this much a month. If you don't pay your bill, we'll just float away.
It really depends on how our client wants it, right? Because since we can actually deploy it wherever we want, and we can have different contracts with different clients. So in that sense, you can actually have a leasing model if it benefits us, right? So that's how they're going to see it. So if a certain client asks for a leasing model, then you have to see how many power barges have you already deployed, what's your revenue stream, and whether a leasing model would be suitable for you, and then you can figure out. It's again, contracting on itself is a big topic, from turnkey EPC contracts and everything. So yeah, leasing model for sure.
Cool.
It can work.
So in terms of the customer, then do you foresee this as being like a ship pulls up to a place, connects to the grid, and is there for a long time? Or is this, I mean, years and years and years as they maybe build out their own on land energy systems? Or is this going to be like following natural disasters like, you know, hurricanes and stuff like that, providing electricity? What's more likely, like sort of a long-term partnership with an island country or something like that, or kind of chasing around disasters.
No. Absolutely, it's for long-term deployment. And you might think that governments are like governments or owner operators are much more into building land based. However, it takes a lot of time and a lot of socioeconomic support that is required to build such mega projects on land because of the site implications and people living by the site getting affected. So this was quite if you think about it, it's kind of like a subscription scheme, right? So you come in, you plug in, whenever you don't want it, you cancel it. But of course, contracts will be there to see how long, how often you can cancel and stuff like that. But it's quite desirable from a client perspective because they don't have to worry about site rehabilitation, they don't have to worry about decommissioning, they don't have to worry about constructing like preparing exhaustively a site for constructing. Of course, the power barge might need some modification to the harbor site, but not at a scale which you would do for a nuclear power plant or a coal power plant.
What happens after 24 years then? Can you like just
Go it back to decommissioning facilities. So we are also looking into that. So we are looking into not just like the kind of design, construction, operation. We are already looking into decommissioning plants. So it's already in the go because, as I showed in the slide, we are also aiming to reprocess the fuel, so to use it for our next CMSR power barge fleet. So in a sense, we are already looking into centralized decommissioning facilities, similar to construction and centralized commissioning and construction facilities, because that's how normally you tend to do in a shipyard. So we try to see how we can tailor it for our business case and for nuclear.
Awesome. Anybody else have any other questions?
Oh, I have one. So you got a liquid fuel salt, and you're on a boat.
Yes.
What if we are experiencing some turbulence? What prevents the fuel salt sloshing around and messing? Would that mess with the neutronics? Is that a concern of the liquid kind of going on?
Absolutely, these kind of evaluations are done for the safety case for us, and also what you are saying is in technical terms it's defined as pitch and roll, and the thing and in maritime it's very common to actually have specific requirements for pitch and roll for every equipment. So the thing is that you don't do a safety a seismic classification for like on a system level, but here in maritime you even try to evaluate the movement and how it affects the stability and integrity up to a component level, and it has been taken into account. And since it is liquid, you can actually shut off and shut on whenever you want. So that was one of the that was one of the good points of molten salt reactor, because if you don't want to produce power and you want to store it somewhere, you just pull the plug and drain it, and you just stop the reactor. So imagine you get a monsoon warning. Absolutely, you can shut down the reactor, drain everything, and keep it idle.
You're saying when you drain it, that means you're also draining it out of the moderator. Because
you would have separate draining. You will drain it from the reactor core.
Okay.
So fuel salt will be draining into a different tank. Moderators will drain into a different tank. So you wouldn't have any mixing. So those considerations are already given.
Interesting. So is the moderator like in like different tubes than the fuel salt, or is it separated?
If you consider a shell and tube heat exchanger, you have a tube and a shell side, right? So inside the
Say that again.
So like it's like a shell and tube heat exchanger, right? Because you have one fluid in the tube and one fluid of the shell.
Okay.
And the thing is that the fuel is in the tube and the moderator is of the shell.
Okay, cool. All right, that makes sense. So they're, yeah, so you can drain them separately.
Yeah.
Awesome.
I had a question, Hannah here.
Yes,
I
Hannah.
seen something, it was a floating nuclear power plant, and I think it was the early concept stage, and it was a charging station for electric yachts. Is that something, you know, is there going to be electrical freight shipping that's going to need to be recharged at various points throughout the world, throughout the seas, where this barge could actually be a charging port for ongoing travel?
Okay. I don't think that's the goal, because if you want like you want charging ports for like transportation in the maritime sector, right? Like if you have electric powered, so in this case you will have a completely different case, right? Because you want the stations to be in the middle of the ocean, where
Yeah,
a lot of things are unpredictable.
yeah.
But we don't want that. We want to make sure, we want to have something which is more tangible, some environment which we can control. Of course, even though it's offshore, we're gonna make sure that we have some backwaters and stuff like that, so we can control the environment. So it's not intended for that purpose.
It's not intended for out at sea. That's a very different scenario.
Yeah.
Okay.
Cool. Thanks, Vighnesh.